Welcome to my demonstration. What I'm going to show you is the Gertbot controlling DC brushed motors and stepper motors in the basic operation mode. What I have here is a Raspberry Pi, and on top of it are two Gertbots. They are connected by this cascade cable. The bottom Gertbot controls two stepper motors, which takes up all of its 4 output channels. The top Gertbot controls two DC motors, which takes up only 2 of its 4 output channels. To demonstrate all these features, I'm going to start up the GUI. This is the debug and development GUI, which allows you to control all the boards in various ways. First, going to connect, and it's going to look for Gertbots out there, and found 2.1, board 0 and board 2. I don't need the log file at the moment. I'm going to park it up here. So I have to know that board 0 is the bottom one connected to the stepper motors, and board 2 is connected to the DC brushed motors. So I start with board 2, DC brushed, and here I can set the operation mode of the output. And this is DC brushed. And the other motor as well, I'm going to set that to DC brushed. Now I'm going to start the motor, and we're going to see what's going to happen. Nothing happened. But what has occurred is at the moment there's a fiercely blinking LED at the back here, which you unfortunately can't see, which indicates an error appeared. To find out what the error is, I press the read error buttons, and in the log file it says board 2 enable 0 was negated. This means that on board 2 motor 0 the enable, which is the high current high temperature output, indicated there was a problem. So what we have here is a very high current, and the short circuit protection kicked in. That is because we have a big motor and a powerful supply, so we get a very high inrush current when the motor starts up. To prevent that short circuit from kicking in, there's an inbuilt feature here which says I want to start up slowly, which is the ramp up mode. And we can set quite a number of ramp up times. In this case, we're going to set half a second. So now the system is set up that the motor is started from 0 to 100% duty cycle in half a second, which eliminates the high inrush current. And it now starts. I can stop it and run it in the opposite direction. And I can do the same for the other motor. Here we're going to go for a much higher ramp up time of 2 seconds to demonstrate what's happening. At the moment the stop time is set to 0, so the motor stops immediately. I can change that as well. I can change that to sort of 1 second here. So now if I start it up, it starts in 2 seconds and stops in 1 second. That mechanism is also used if you reverse. If you go from full one direction to the other direction, it takes 3 seconds. 1 second to stop, 2 seconds to start up again. All that still works with the duty cycle, so you can change your duty cycle to let your motor run much slower. Now I'm going to demonstrate the stepper motors. So we have to set this channel here. We go to board 0. The first channel we set to stepper motor, gray coded. What you see here is the other channel is disabled because a stepper motor requires both of the 2 outputs of the bridge. And this one we can change as well. It's set to 100 Hz 10 steps, so if you press the button, the motor takes 10 steps. And the other motor as well. And I can go, of course, in the opposite direction. These stepper motors have a rotational degree of 0.9 degree per step. That means it takes 400 steps to go round. So if I set to 400 and I start it, it takes exactly 400 steps and it stops. And it's in the same position as it started. We can do the same with the other side. But here I'm going to change the frequency to 200 Hz, so this one runs a bit faster. Or I can go to 400 Hz. I'm going to run 400 Hz, 1 second. The limitation is not so much set by the application. The Gertbot can drive stepper motors up to 5 kHz. The maximum speed is more limited by the mechanical capabilities or more the limitations of the motor. These motors are very good, they can run even at 800 Hz. The frequency is very accurate, which I can show you here. I'm going to start both motors at 100 Hz. I'm going to give them lots and lots of steps so they don't stop very quickly. I'm going to start them, both running at 100 Hz. Now what I can do, I'm going to go to this one and change it to 101 Hz. What you hear there is the interference, the beat of the two motors against each other. I can even make it 0.5 Hz. So you can run your stepper motors, two of them, very accurately. In the next session I'm going to show you more of some of the other features which the Gertbot offers.